Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Today is going to be a bit of a review. We're going to be reviewing ratios, and specifically, we're going to be reviewing equivalent ratios, otherwise known as proportions. So I'm going to write it here, proportions. You can also say a proportional relationship. So what does a proportional relationship look like? Well, let's look at this example right here. We see that Stephanie runs a website for a local sports team and gets 50 views every hour. In other words, every 1 hour. So 1 hour, 50 views every 1 hour. And this is this table shows us the ratio. Remember, ratio is a comparison between two things. What are those two things that we're comparing here? Well, we have views per hour. Let's think of this as a fraction where we have views on the numerator and we have hours on the denominator. So here we have the information. So we have 50 views in 1 hour. We have 100 views in 2 hours, 150 views in 3 hours, and 200 views in 4 hours. Notice, ladies and gentlemen, that if I were to think of these as fractions rather than just a table, we can see that these fractions are all equivalent to one another. 50 over 1 is the exact same thing, or rather it's equivalent as 100 over 2, which is equivalent to 150 over 3, which is equivalent over 200 over 4. The question is, how do we know that? How do we know that these truly are equivalent? Well, if we can remember, whenever we have equivalent fractions, let's say two of them, for example, 50 over 1 and 100 over 2. Ladies and gentlemen, if they're equivalent, then I should be able to either multiply or divide. In this case, I can multiply 50 times 2 to get to 100. And if these are indeed equivalent, I should be able to do the same thing with the denominator. In this case, multiply it by 2, the same factor. I'm multiplying both by 2, and it should give me the denominator of the other fraction. So if 50 times 2 is 100, then 1 times 2 should be, that's right, it does indeed give me 2. Notice that that also works over here. 50 times 3 is 150. And if I multiply 1 times 3, does it give me? Yes, it gives me 3. It works out. And I can do that with other fractions here. For example, I can do 100 times 2 is 200. So I should be able to multiply 2 times 2, and 2 times 2 should be 4. And yes, it indeed gives me 4. So it works out. Because whatever I do to the numerator, if I do the same thing to the denominator, the resulting fraction will be equivalent. As long as you're multiplying both the numerator and denominator by the same factor, or dividing both the numerator and denominator by the same factor. So that works. Another way that you can test this out, ladies and gentlemen, is by and here, let's go back. I can just erase some of these things. We can cross multiply. I can take any two of these relationships. For example, let's say that I took this one, okay? Why do I want to take these two? 150 over 3 and 200 over 4. Because I can not multiply 3 times anything simple to make it into a 4. But what I can do, guys, is cross multiply. 3 times 200 will give me 600. And I know that 4 times 150 is actually 600 also. Notice that they match, so they are equivalent. And that's always going to work in this process. I can take, let's say, these two. 2 times 150 is 300. And 3 times 100 is also 300. So ladies and gentlemen, again, it works out. These fractions are all equivalent to one another. Therefore, I can say that this is a proportion, or rather a proportional relationship. They're all equivalent. So that should be reviewed. That should be a review from what we've done in the past. And if it's not, I encourage you to watch some of the videos from some past lessons. But ladies and gentlemen, the question is, what can I do with this information? Well, let's look at these two variables. We have views and hour. If you think about it, hours, that happens first. In other words, as time goes by, as the hours go by, more views are accumulated, and it doesn't work the other way around. It's not like if you suddenly get a ton of views, then a ton of hours are going to go by. That doesn't make any sense. So ladies and gentlemen, I can say that time is my independent variable. This is my independent variable, whereas views depend They depend on time, which does not depend. In other words, it's independent. And so that helps me see that in a way, time or hours has to happen first. So if I'm graphing something, guys, I have an X and a Y. So because time happens first, that's going to be my X, and views is going to be my Y. Now, why am I doing this? Well, because if I look at this in a graph, as I can see down here, notice that time is in my x-axis, which is the bottom axis down here, and views is in my y-axis, which is the axis up here. So as I can see in the table, I saw that when time, so I'm gonna do it the other way around now. Time and views. So when we had 1 hour, we saw that we had 50 views. Whenever we had 2 hours, we saw that it was 100 views. Sorry. When we had 3 hours, we saw that it was 150. And when it was 4 hours, we saw that it was 200, etc. So remember, time is my X, views is my Y. Okay, so when time is 1, so here is time, here's 0.5, here's 1. We see that views is supposed to be 50. So notice that it's going by 25. So we have 1, 50. X is 1, Y is 50. Now when X is 2, so we go 1, 2, Y is supposed to go all the way up to 100. So we're right here. 2, Y is 100. If we keep going, when X is 3, Y is 150. When X is 4, it's 200. So we have 4, 200, etc., etc., etc. So notice that I am slowly filling up this table, right? And notice that I can use this to predict where it would be after that. So when it's 5, I would expect it to be 250 because it's going up by 50, right? When it's 6, it would be 300, etc. Now here we can see a pattern. As I'm graphing this, ladies and gentlemen, notice what happens when I put all the points together. Okay, if I just use a line to go through each of the points, ladies and gentlemen, there's 2 things that I want you to notice. Number 1, the line, it's not just a line, it's a perfectly straight line. So it makes a straight line. And number 2, notice how that line is crossing through the point where X is 0 and Y is 0. Right here, right at the corner. Ladies and gentlemen, that is known as the origin. And so I'm graphing this relationship. I'm graphing this proportional relationship where each of the ratios is equivalent. And when I did that, ladies and gentlemen, the graph gave me a perfectly straight line that goes through the origin. And that will always be the case. And I need you to know that whenever you graph a proportional relationship, or rather the graph of a proportional relationship will always be a perfectly straight line. In other words, every single point that's part of the line will be in line with each other, and that line will go through the origin, which is over here, down here at the bottom. Okay? So notice that I can work the other way around. For example, let me find a point that is not on this. Let's see the point right here. This point is where my X is 4.5. So time is 4.5 hours. So that's my time. And that's going to be right here, which is 225. So when my time is 4.5 hours, 125 views will have come through. Let's choose a different point on this line. Let's say we have 8. So in 8 hours, where is the line? It's right here. That means that you should have 400 views. So for 8 hours, there should be 400 views. Notice that I can use that and add that to the table. So if my time was 8, then it would be 400. Notice that that is in line with all of these ratios. It would simplify all the way back to 1/50. Okay, so ladies and gentlemen, that's how I can go from a table to a graph, and graph to a table. Let's observe a different one. Let's see if we can get that same pattern again, where if we look at a table, it's going to give us a perfectly straight line that goes through the origin. So here we can see both the table and the graph. So we see that Angie burns 225 calories in this workout every 30 minutes that he rides. And it's not Angie, it's Augie actually. Augie burns 225 calories for every 30 minutes. So obviously I'm comparing calories and time. Calories and time. He's consistently burning 225 calories every 30 minutes. Now, firstly, guys, notice that time happens first. Okay, time's going to happen no matter what. That is independent. That is going to be my X. And notice that we can see that here on the graph, that time is on the X variable or the X axis. And calories burned is going to be Y. Okay, that's going to be dependent on the time. So that's going to be up here on my Y. Variable. Okay, so let's put in the information. We have 225 calories burned every 30 minutes. Well, notice that I can use this to see how many calories are burned in 1 hour, because 30 minutes, an hour would be 60 minutes, so that would be times 2, right? So we've multiplied 225 times 2. Well, 225 times 2 is going to give me 450. All right. I can go ahead and put these on the graph already. In fact, 1 time is 30. Calories burned is going to be 225. Notice that these squares going up are going by 25. So we have 25, 50, 75, 100, 125, 150, 125, 175, 200, 225. So if I were to just draw a line, so at 30, we go 30 goes up all the way to when it's 225. So that's where the point would go. Right, so that's why the point is right here. All right, now when it's 60, we have 450. So here's 60, so 60 is going to go up to 450. Here's 400, 425, 450. So we are up here. And already you can see that it's going to make a straight line. Now, what if we just wanted to go to 10? All right, well, 30 divided by 3 is 10. So 225 divided by 3, if you actually work that out, you would see that it would give you 75. 225 divided by 375. So whenever we have only 10 minutes, we're going to go up to 75. So I'm going to put a point right here. And whenever we have 50 minutes, well, 10, let's use the 10. 10 times 5 is 50. 75 times 5 is, I believe that's going to be 375. Let me do 75 times 5. 5 times 5 is 25. 5 times 7 is 35. 36, 37. Yes, that's 375. So at 50, we're going to be at 350. It's going to be 325, 50, 375. All right. So let's see if we did this correctly. Remember, if this is proportional, it should be a perfectly straight line. So let me go ahead and draw a line through all of these points. Okay. So I'm going to start with this top one, and I'm going to see, do all the points go straight through the line? It does. Not only that, ladies and gentlemen, not only is it a perfect straight line through the points. Okay, there's not a point that is not on the line. They're all exactly on the line. Does the line go exactly through the origin, the point 0, 0? It does. So notice, ladies and gentlemen, that once again, we are seeing that the table not only matches the graph, but also the graph of this table makes a perfectly straight line that goes through the origin, because again, the graph of a proportional relationship will always go through the origin and be a perfectly straight line. Again, if you think of these as fractions, all of these fractions are equivalent. 225 over 30 is the exact same thing as 75 over 10, which is the same thing as 450 over 60, which is the same thing as 375 over 50. Okay. So that's pretty much it, ladies and gentlemen. We can match the table with the graph, and we can match the graph with the table. That's always going to work. So if we look at the assignment that goes along with this, you are given a whole bunch of tables, which I'm trying to get through. There it is. For example, this first one. We have weight in pounds and cost in dollars. So we see that as weight goes up, so this is my X, the cost in dollars is going to go up as well. So you would have to match this with a graph where it has these points where X is 1, Y is going to be 3. X is 2, Y is going to be 6. X is 4, Y is going to be 12. X is 5, Y is going to be 15. And you're going to notice that that graph will make a perfectly straight line. It's going to have these points and they will go through the origin. And it's going to be the same for each of these different tables. All right, ladies and gentlemen, I hope you found this video helpful. And with that in mind, I will see you next time.